So we talked about, just to recap what we've been doing, we talked about prisms and cylinders, which had two bases to it. Basically a top base and a bottom base, or a front base and a back base, depending on like how we drew it and how it was turned. But it had two bases. And so the surface area and volume formulas for those were had to do with, here's the two bases, and then here's the what we call the lateral faces, which were everything else, all the other sides. So scroll up a little bit in the notes. These were the prisms, and then these over here where the arrows are pointing are the lateral bases, or the lateral faces. So those are, anything else that's not a base is called a lateral surface. So when all these problems talked about lateral area, that's what it was talking about. It was talking about this isn't the base. And then we talked very briefly about spheres. And now we're going to talk about pyramids. And what makes pyramids different is that pyramids have one base, instead of having a top base and a bottom base. It just has a base at the bottom, and then all the other, all the vertices of the base, all the other points of the base are going towards this single point at the top. That single point is called the apex of the pyramid. That's the very top of the pyramid, and all the points down at the bottom are building up towards that top. That one point up here. Okay? Name of the solid is a pyramid. And it only has one base. So, one base down here. And all the rest of the points are building up towards the apex. Now, the tricky thing about pyramids is that when we talk about the height, we can talk about the height two different ways. We have the height, if you think about, like, if you were to go to visit the Great Pyramids of Egypt, for example, there are two different heights that you could talk about. There's the height if you were to somehow think of it as like a mountain that you were scaling up and you were going up the side of the mountain. That would be a height that you were climbing up. And that height is over here, and we actually call it a slant height. Slant height. And it's called a slant height because you're slanting on an elevation. And you'll see it abbreviated as a cursive L, like that. That's slant height. So that's scaling up the side of the pyramid. Or when we talk about cones, it's going to be the same idea. You're scaling up the side. Then we also have the height if you're just, let's say you're inside the pyramid and you're standing at the dead center of it and looking straight up to the top. That is what we actually call our height. And what we use H to abbreviate it. Remember, in prisms, the height was just the vertical distance that connected the two bases. So again, in this case, the height is a vertical distance. You're standing dead at the center and you're looking straight up. That's the height. Okay, surface area of a pyramid. And the difference is that the slant height is going to be used for the surface area formula, and the height is going to be used for the volume formula. The slant height is used in the surface area because it's the height of these triangles that make up the lateral faces. It's the height of these triangles that make up the lateral faces. So you'll see in this formula, surface area, and you can look back at the difference between the formulas. Remember that the surface area of a prism had twice the area of the base. Why did it have twice the area of the base? Because it had two bases. So we had to double the area of the base. Not here. Here we have one base, so we need one area of the base. And just like we wanted the perimeter times the height in the prism, in the pyramid, we want the perimeter times the slant height. So this distance times this distance, and then times 1/2. Why 1/2? Because these are triangles. So we're basing it off of the 1/2 base times height formula that you have for triangles. That's your surface area of a pyramid. And this part, again, this part is the lateral area. So when we have, when it talks about finding the lateral area, that's what it means. Oh, I get to draw the net. Okay. Do my best here. The way that it would unfold two-dimensionally is basically you would have the square base, and then here's all the lateral faces like this. And then they would all fold up onto each other. That's the idea. That's what the net looks like. And then the volume is 1/3 area of the base times the height. The height, straight vertical up and down, standing at the center, looking straight up. All right? And a lot of times in these problems, you're going to be given one of the two heights and being asked to find the other. So you'll need a lot of Pythagorean Theorem. Because you'll know, and that'll be done with the Pythagorean Theorem will look like this. You'll have the height here, okay? And then you'll have a distance that comes out this way, and then your slant height. And that's going to make a right triangle that we're going to do Pythagorean Theorem on. Here's the height. Here's the slant height. And so you're going to be given those things and being asked to solve for the other ones. Remember, we're going to find this part up here, and we're going to find this part over here. So let me actually draw those arrows. This is where we're going to find the area of the base, and then this part of the formula is going to be found over here. And then volume, 1/3 at the base times height. All right, let's get started. Base area. Well, first we need to figure out what the base is, and that'll help us name this this solid. Name of the solid, we name pyramids just like we name prisms. We name it after its base. So this is a pyramid. A pyramid that has a base that is a, well, how many sides does it have? It has 1, 2, 3, 4, 5 sides. So if it has 5 sides, that will be a pentagon. So this is a pentagonal pyramid. Pentagonal pyramid. Area of the base. Well, area of a pentagon, we did this a couple weeks ago. Area of a pentagon is 1/2 ASN. Well, fortunately for us, we know A, we know S, and we know N. A is apothem. That's your distance from the center, drop down a height. That's this distance right here, which is 5.5. Side length is right here. It's 8. Number of sides, well, it's got 5 sides. It's a pentagon. So we got 1/2 the apothem, which is 5.5. times the side length, which is 8, times the number of sides, which is 5. Plug that all in, you should get 110 for the area of the base. So that's going to go in these parts of the formula. Anytime you see the capital B, it's 110. Lateral area. This is where it gets a little bit trickier because it's this part of the formula. 1/2 the perimeter times the slant height. Well, perimeter's not too bad. We know how to find perimeter. Perimeter, we add up all the sides, and all the sides are 8. So 8 plus 8 plus 8. Well, there's 5 sides, so we need 5 of these. And that is 40. And our slant height, here's where Pythagorean Theorem comes in. We need this triangle. It's actually drawn for us in the diagram. This is the triangle we need. And so if I draw out that triangle separately, like this, then I've got, well, this is 4.8. And this distance down here is 5.5. It was the apothem. And I want slant height. So this is where our Pythagorean theorem comes in. We're going to have slant height squared equals 4.8 squared plus 5.5 squared. Put this in the calculator and we get 53.29. That's 4.8 squared plus 5.5 squared. So then we take square root of both sides, get rid of squaring. And our slant height becomes see, is this approximate or exact? Let me double check. Square root. Oh, it's exact. It's exactly 7.3. Good, good, good. So not approximate. We want equals. Equals 7.3. So the slant height is exactly 7.3. And remember, you can double check. Hypotenuse should be our longest side. And 7.3 is bigger than these two numbers. So that is your longest side. That means 1/2 perimeter times the slant height. That's going to be 1/2. The perimeter is 40 times our slant height is 7.3. So that equals 146 for our lateral area. And the reason we're doing these separately is that means once we get to our surface area and volume stuff, the formulas are a lot less messy to deal with. And that's because we already did the messy stuff up here. So once we get to the surface area, well, area of the base is 110. The lateral area is just this part, and we found that part up here was 146. So the answer is just 110 plus 146, which is 256. And the surface area is in meters squared. Volume is 1/3 the area of the base times the height. Well, the height is this distance right here. Here's my height. Goes from the center straight up to the top of the pyramid. That's 4.8. 4.8. And capital B, that's area of the base. Well, we did it up here. It's 110. And that should give you 176. And since it's a volume, it should be in meters cubed. Meters cubed for volume. Meters squared for surface area because it's an area. Just so you remember, surface area, the question we're answering is if I wanted to wrap paper around this shape, how much wrapping paper would I need? Or if I wanted to like design a label for this with a box that has this shape, how much space do I have to work with? That's surface area questions. Volume questions are filling. So I want to fill this with like water or sand or something like that. How much space do I need to fill this entire container? That's a volume question. Volume's in meters cubed. Surface area is in meters squared. Again, I'll leave that up for another moment if we need to write down. Let's do one more pyramid. And then we'll move on to cones. Oops. Scroll down like that. There we go. All right, now you'll notice that the place that you need to do your Pythagorean theorem is going to change this time. Let me get one more thing here. There we go. There we go. All right. So we're going to stroll through surface area. And then when we get to volume, it's a little bit trickier. So again, I'll write down the formulas at the start so that we know where we're headed. And if you're thinking about, SAT or PSAT or those kind of things, you're actually given these formulas on the SAT, or the volume formulas. So some of the area formulas that I talked about are good to memorize, like area of a triangle, area of a rectangle. Those are useful to you even as you're moving forward into Algebra 2. Those are good formulas. You're going to run into some problems that ask you to know area of a rectangle, for example. But surface area or volume, not often that they would that you would be asked to know those off the top of your head. Oh, name of the solid? This is still a pyramid. And its base is, let's see, that is a square. So that is a square pyramid. So area of the base, well, area of a square is just its side squared. Or length times width, but the length and width are the same. So our side length is 20, square it. That's 400. Nice and easy. Lateral area. This is also pretty easy. Perimeter. Perimeter, we add up all the sides. Well, all the sides are 20. And in a square, we have 4 sides. So 20 and 20 and 20 and 20 is 80. 20, 40, 60, 80. Slant height, we're scaling up the pyramid. Here's our slant height. It's 30. That time it was given to us. So when we do 1/2 perimeter times slant height, we're going to go 1/2 80 times 30. And that's going to be 1,200. So we got our area of the base. We've got our lateral area. So now for surface area, all we need to do is we need to add those together. Area of the base, it was 400. Boom. 1/2 the perimeter of the base times the slant height. Remember, that was all done up here. 1/2 the perimeter of the base times the slant height. It was 1,200. Boom. Right there. Add them together. Boom, boom, bam. 1,600. Millimeters squared for a surface area. Units squared for surface area. All right, and now all we need to do is do our volume. So this has been pretty easy. We got 1/3 area of the base times the height. Man, we're going to cruise through this problem. Area of the base was 400. Done. And then our, we don't have the height, do we? Man, I thought we were done. Thought we were all the way done. But nope, we got to do Pythagorean Theorem. Here it is. It strikes back. So here's our triangle. Let's see if I can draw it. Here's the height we're looking to find. Dropping straight down into the center of the pyramid. There's the height we're trying to solve for. So if I'm connecting it in the triangle, right there. Let me do that again so you can see how that triangle gets drawn. Because you'll need to draw it in all of these problems. Okay? So you're going to have your slant height. This is going to end up being the hypotenuse. There's your slant height. And then here's the height, which in this case is what we're trying to solve for. Now the height drops down right to the center. So you've got this distance from the center out to this side. And that's the distance you want to draw to complete the triangle. There, there, and there. If we're redrawing it. And the slant height, here's the slant height, it's 30. And I know that this is my height that I'm trying to solve for. Now this distance, well, since I went from the center out to a side like this, well, that means I went halfway across the square. Halfway across the square. It's the same as if I started here and went out to here. It's halfway across since it's from the center. And halfway across 20, it's 10. So that means we're going to do 30 squared. Hypotenuse goes on the left, equals 10 squared plus h squared. 30 squared is 900, equals 10 squared is 100 plus h squared. Right, we're just solving for h. Subtract. And then we're going to take the square root of both sides. Oh, 800, if I want to simplify square root of 800, we're just plugging into the calculator. So if you just want to do square root of 800 when you're putting it in the calculator, then that's fine. So 20 square root of 2 is my height. I'll give you a decimal. It says to round to 2 decimal places, so that's what we're going to do, which will give us approximately 3771.24 millimeters cubed. Surface area, guess what? It's still area of the base plus 1/2 perimeter times the slant height. The only difference, here's the only difference. Perimeter, we don't talk about perimeter for circles. This shape does not have a perimeter. It has a circumference. So instead of P for perimeter, we're going to do C for circumference times the slant height. So it's the exact same formula, just using the fact that we're talking about circumference for circles instead of perimeter. Other than that, exactly the same formula. And volume, it's exactly the same formula. 1/3 area of the base times the height. Just like with the pyramid, you're using the height when we do volume and the slant height when we do surface area. And just like with the pyramids, you're going to need Pythagorean Theorem with this triangle right here to solve for your height or your slant height or whichever. So we'll do a couple of these and then we'll be done. And I'll just write these formulas down again so we know where we're going with this. Surface area equals area of the base plus 1/2 the circumference now instead of perimeter times the slant height. And then volume, 1/3 area of the base times the height. Just like I did with the cylinders, I'm going to keep it in terms of pi until the very end of the problem. I'm going to keep it in terms of pi until the end of the problem. And some of the problems on the Pearson assignment, some of them will ask you in terms of pi, some of them will ask you to round. And it should say, like, right beneath the answer box, it should say something like, leave your answer in terms of pi, or round your answer to 2 decimal places. Something like that. So keep an eye on that. Here we go. Area of the base. Whoop. Whoa, whoa, whoa. Area of the base. There we go. Area of the base, well, it's a circle. So area of a circle, that's pi r squared. Again, it'll be helpful if you know that formula, especially because where we're headed next after we're done with this, we'll probably spend some time next week reviewing these, and I'll give you a review assignment on it. But the last chapter that we're going to talk about for the year, the end of the year, is going to be all about circles. So if you know these formulas for area and circumference, that's going to be really helpful for the last chapter. Pi r squared. R is the radius. What's my radius? Well, the radius is the distance from the center of the circle out to a point on the circle. This distance right here is my radius. So the radius is 15. Pi times 15 squared. Which equals, well, 15 squared is 225. So we'll keep it in terms of pi and say 225 and then stick a pi on it. .225 pi for area of the base. Lateral area. 1/2 the circumference times your slant height. Okay, this is the tricky part. First off, circumference. Well, the formula for circumference is 2 pi times the radius. 2 pi r. If you're having trouble telling these apart, I've said this before. If you're having trouble telling these apart, remember that area is in units squared. So area is the one that has the squared on it. And then circumference just has the units, so 2 pi r. 2 pi r, so that is 2 pi times my radius is still 15. So we multiply out everything aside from the pi. 15 times 2, so double 15, I get 30. Stick a pi on it. Slant height is, aw, dang. We don't have it. It's this distance, isn't it? Here's your triangle. Let's draw it out separately. And we got to do Pythagorean Theorem. Here's 15. My height is this distance right here. That's 20. And then my slant height is what I'm trying to solve for. So slant height squared, that's the hypotenuse, so it goes on the left, equals 20 squared plus 15 squared. Uh, 20 squared plus 15 squared, that's 225. So that is, what is that, 625? 625. Take square root of both sides. And I get my slant height to be exactly 25. That's Pythagorean triple. It's exactly 25. Remember, hypotenuse, the longest side opposite the right angle, that's what goes on the left side. And we get exactly 25. 1/2 circumference times the slant height. 1/2. Circumference is 30 pi. And our slant height is 25. Oh, let's see. Half of 30 is 15, and 15 quarters would be just under $4, $3.75. So 375. And then keep the pi on it. There we are. That's our lateral area. That is this part of the formula. So when we go to plug in for surface area, the hard part is done. Hard part is done. It gets easy from here. Area of the base, we already did it. It's 225 pi. 1/2 the circumference times the slant height, we already did it. It's 375 pi. We don't need the 1/2 because we already took care of it up here. So we don't need to talk about it again because we already took half. So just add them together. And that's exactly, the exact answer would be 600 pi. So if we asked for your answer in terms of pi, you'd leave it like that, put the units on it. If we asked you to round it to the nearest hundredth, you'd do 600 times pi in your calculator, and you get out 1884.96 to 2 decimal places. 1884.96 yards squared for surface area. Volume, 1/3. Area of the base, times the height. The height is this distance right here. Remember, standing at the center of the cone, looking straight up, 20. Exact answer, 1,500 pi. If we round it, .39 yards cubed. Yards cubed. Here the base is pi times the radius squared. Well, the radius is 3. It's that distance from the center out to a point on the circle. So 3 squared is 9. Stick the pi on it. There we go. Lateral area. Lateral area is 1/2 the circumference times your slant height. Well, the circumference, that's going to be 2 pi times the radius. Well, the radius is 3. So 2 times 3 is 6. Stick the pi on it. Slant height is this distance. It's the distance scaling along the side of the cone. That's 5. So we got 1/2 the circumference, which is 6 pi, times your slant height, which is 5. 6 times 5 is 30. Half of 30 is 15. Stick the pi on it. So when we go down here to the surface area formula, we just need to add them together. And we've got 9 pi for my area of the base, 15 pi for circumference times the slant height. Add those together. That should be exactly 24 pi. If I wanted to round it, you round it. .70 meters squared. For surface area. For volume, volume is 1/3 times the area of the base, that's 9 pi, times, no, we were almost done. We don't have the height. Now we got to do the height. Here it is. Here's the height. Straight from the center, looking directly up to the top. There it is. Height we don't know. Here's 3. Here's 5. Remember, it's the height drop down, the slant height over here, and then our radius, distance from the center out here, that's what makes up our triangle here. So we have 5 squared. 5 is our hypotenuse. It goes on the left. Equals 3 squared plus h squared. 25 equals 9 plus h squared. You should get 4 for h. Subtract, take square root, you get 4. And multiply that out, we're going to get 12 pi. Which rounds to 37.7 meters cubed. meters cubed since it's a volume.